Welcome to my channel. Today we are going to discuss about some of the problems from the subject circuit analysis. Okay, so which is very used in order to prepare the TRB examination. So already I posted some 6 videos relating this circuit analysis subjects. Okay, so in that the previous question bank, okay, previous question paper, the TRB question paper is solved in the previous videos. If you want to learn that video, I will give link in the description box or in our channel in the name of TRB Polytechnic exam. There is a playlist is there. You just check it. Okay. So the first question you see, this is the given diagram, circuit diagram. So here the given data you see, when Vs is equal to 0, the current I is equal to 3. And when Vs is equal to 12 volt, what is the value of I? Okay, this is the question. So you see the diagram in that circuit, there will be a one voltage source Vs and one current source Is is there. Okay, and the 3 resistances connected. So current flowing through this resistor, this 2 ohm resistor, it is called it as a I. Okay, so our aim is to find out this current I whenever the value of this voltage source Vs is equal to 12 volt. Okay, this is the question. So in order to calculate this current I, so one current is given. What is that current means? Whenever this Vi is equal to 0. Okay, this voltage source value is 0 means at the time the current flowing through this 2 ohm resistor is 3. Okay, it is given. So using this data, we are going to find the current I whenever the value of Vs is equal to 12 volt. Okay, instead of 0, whenever this voltage source is 12 volt, what about the value of I? We have to calculate. So the first thing, you just note down the data. When Vs is equal to 0, the current is 3 amps. Okay, our aim is to find out Vs is equal to 12. Okay, that is in order to solve this problem. So we are going to use the method superposition principle here. Okay, so what is mean by superposition principle? In superposition principle, if the circuit consisting of 2 sources means if we want to find out the current flowing through this resistance means first we have to make one source active and another source deactivate. Okay, so one source we have to activate. Because of this source, what is the current flowing through this 2 ohm resistor? We have to find out. We have to take it as a equation number 1. Okay, similarly in next thing, we have to make this source as a this first source we have to deactivate, that is that source value as 0, and we have to activate this second source. At the time we have to find the current I. Okay, so the total current flowing through this 2 ohm resistor is nothing but it is an addition of the first current as well as the second current. It is called it as a superposition theorem. Okay, so here you see the value given is whenever the Vs is equal to 0, the current I is equal to 3 amps. Okay, so Vs 0, this is this first, the second source 0 means at the time the current flowing through this 2 ohm resistor is given as 3 amps. Okay, that is you just consider as a equation number 1. Okay, then the next thing, our aim is to find out the current I whenever the Vs is equal to 12. Okay, so in superposition theorem, in second condition we have to make Is 0, and this Vs value as we have to make it as a 12 volt. At the time we have to find the current I. Okay, so if the current Is is 0 means this current source it is a open circuited. So that's why you see the diagram. So this current source is open circuited. So that's why we can get the circuit like this. Okay, so now because of this voltage source 12 volt, what is the current flowing through this 2 ohm resistor? We have to find out. So in order to find out this current, so here there is a open circuited, so this 2 ohm is neglected. Okay, only there will be only one KVL circuit. You just apply KVL to this circuit. We can get the equation 12 is equal to 2 into I plus 2 into I. Okay, so 12 is equal to 4I. From that the current I is equal to 3 amps. So the current is calculated. Okay, then according to the superposition theorem, so our aim is to find out the current flowing through this 2 ohm resistor whenever the Vs is equal to 0 and the Is value. Okay, so therefore according to the superposition theorem, So the total current flowing through this 2 ohm resistor, that is the actual I. Okay. So that I is nothing but it is addition of current flowing through that 2 ohm resistor whenever the Is is equal to 0 plus current flowing through this 2 ohm resistor whenever Vs is equal to 12 volt. Okay. So the current is 3 plus 3, which is equal to 6 amps. So 6 amps is the correct answer. Okay. So this is the correct option. So if the data is given like this, means we have to use the principle, superposition principle, in order to solve this problem. Okay. Then the next question, the voltage V in the figure is dash. Okay, this is the given diagram. So here the voltage value, okay, voltage across this open circuited terminal we have to find out. Okay, so here you see the diagram. So across this open circuited terminal, there will be a 10 volt voltage source is there. Okay, so so what about the voltage? This open circuited voltage V, which is nothing but 10 volt. Okay, so directly we can write. Then the next problem, the voltage V in the figure is dash. Okay, so here this is the given circuit. This is 5 volt battery, 4 volt battery, one resistor. Here one resistor is there. So voltage across this resistor, okay, this V we have to find out. So in order to find out this V, we have to write the KVL equation, Kirchhoff's voltage law, to this loop. Okay, you see this two thing. This 2 ohm resistor is parallelly connected with this voltage source. So what is the voltage across this 2 ohm resistor? This 4 volt. Okay, so the 4 volt voltage is dropped across this 2 ohm resistor. So this is the plus, this is the minus. Okay, so if you are applying KVL to this loop means, so according to KVL, you see minus to plus, it's a voltage rise. So 5. Then if you are coming here plus to minus, it is a voltage drop 4. Okay, here it's a voltage drop 4. Then if you are coming here minus to plus, voltage rise. Okay, so voltage rise you write in one side, voltage drop you write in one side. So 5 plus V is equal to 4 plus 4. So V equal to 8 minus 5, 3 volt. So voltage across this resistor is a 3 volt. Okay, this is the correct option. So in that, so you just use the KVL. Okay, Kirchhoff's voltage law for this single loop. At the time, you just remember that here one resistor, voltage across this resistor is same as that of this voltage source value. Okay, so if you are taking means, we can get the answer. Then the next question, find V of t of the circuit shown in figure. Okay, find V of t. So voltage across this inductor we have to find out. Okay, voltage across the inductor we have to find out. So here you see the diagram. This is a one current source. This current source value is e power at. This is the current source e power bt, and two resistances of value 1 ohm. This is the inductor of value 1 Henry. So current flowing through this inductor is I. So voltage across this inductor we have to find out. Okay, so here the 4 option is given. So first one, so you know the formula, general formula for the voltage across the inductor. Voltage across the inductor VL is equal to L into di divided by dt. Okay, rate of change of current flowing through the inductor multiplied with the inductance value, it is nothing but a voltage across the inductor. Okay, so first we have to find the current flowing through this inductor. So you see, so there is a two current source. Okay, so because of this current source, current flowing through this branch is e power at. Because of this current source, current flowing through this branch is e power bt. So these two currents are entering in this node, and this current I, okay, the current flowing through this inductor, it is nothing but a addition of e power at, e power bt. Okay, so the current I, you see, the current I of t equal to e power at plus e power bt. Okay, so our aim is to find out voltage across the inductor. So L into d by dt of e power at plus e power bt. So if you are differentiating e power at, we can get e power at into a. Okay, similarly, if you are differentiating e power bt into b. Okay, so here and what about the value of inductor? Inductor is 1 Henry. So you substitute the L value. So finally, we can get the answer A into e power at plus B into e power bt. So you see the option A into e power at plus B into e power bt. So D is the correct option. Okay, so that is the voltage across the inductor. If only the current means current is e power at plus e power bt. But here the question is find V of t. Okay, so using this, we just substitute the current and differentiate it, we can get the answer. Then the next question, if each branch of delta network has the impedance √3 into Z, then each branch of the equivalent star network is dash. Okay, so in delta network, okay, the three resistances are connected in delta network. So here this resistance value in each branch of delta network is √3 into Ez. Okay, this is also √3 Ez. This is also √3 into Ez means what is the corresponding resistance value available in star network. Okay, so already we know the relation between the delta network and star network. Okay, so how to convert the delta network into star network already we know. Okay, so you see the impedance in star network. Okay, ZY. So ZY is nothing but impedance in a star network is nothing but impedance in delta network divided by 3 if the three impedances are equal values. Okay, so here in our problem, the each branch in delta network has the impedance value √3 into Z. So you just substitute. So √3 into Z divided by 3. Okay, so if you are cancelling √3, 3, we can get here √3. Okay, so finally we can get the answer Z divided by √3. So Z divided by √3 is the correct thing. Okay, if delta network values √3 into Z means the corresponding star network is having the value Z divided by √3. Similarly, the reverse problem also it will come. Okay, in that means the impedance in delta network is nothing but 3 times that of the star network. Okay, using that formula you just solve. Then the next question, the minimum number of equations required to analyze the circuit shown in figure is dash. Okay, so this is our given diagram. In order to solve this circuit, so how many minimum number of equations are required? So that is our question. So the minimum number of equation required is nothing but it is depending upon the number of nodes. Okay, number of node except the reference node. Okay, so if the circuit consisting of 3 nodes means the minimum number of equation required is 3. Okay, except reference node. You just remember it. So first we have to identify how many nodes available in our given circuit. So you see this is the one node. Okay, so this is the node 1. Then similarly this is the node 2. Okay, so here you see this one. Okay, this all this node 2. Okay, this is the node 2, this is the node 2. This 3 is connected in one point. This is the node 2 and this is the third node. Okay, and this one is this is the reference node. Okay, this is the reference node. We just discard it. So the number of nodes in our given equation is 3. Okay, so 3 nodes. So in order to solve this circuit, the minimum number of equation required is also 3. So 3 is the correct option. Then the next question, which one of the following in the manufacture of law of conservation of energy? Norton's theorem, Thevenin's, Telegian and Superposition, Telegian theorem. Okay. Then the next question, the average power delivered to an impedance 4 minus J3 ohm by a current 5 cos 100 pi t plus 100 amps is dash. Okay, what is the average power delivered to the impedance 4 minus J3 if the current value is 5 cos 100 pi t plus 100 amps. Okay, so the 4 value is given. So the average power, it is nothing but, you know the formula, the average power is nothing but IRMS squared into R. So where the root mean square current is nothing but Im divided by √2. Where Im is this is the current I. Okay, this is the current I. So I equal to 5 cos, this means this 5 is nothing but Im. Im is the amplitude of the current. So 5 divided by root 2. So you just substitute this IRMS value in above equation. So 5 by root 2 the whole squared into resistance R. Here this is the impedance. Okay, so in impedance, what is the resistance value? 4. Okay, so you just substitute it. So the 5 divided by root 2 the whole squared into 4 is 50 watts. So 50 watts is the correct answer. This is the average power delivered to the particular impedance. Okay, then the next question. The circuit shown in figure represents dash. So you see the equivalent circuit. So in this source side, the current flowing is Is. Okay, in output side, so you see what is the symbol? The symbol indicates the current source. Okay, this is the dependent current source. This dependent current source value is given as A into Is, where A is a constant, Is is a current flowing in input circuit. Okay, parallelly connected with the resistor. Okay, so what is this circuit? VCVS, that is voltage controlled voltage source, voltage controlled current source, current controlled voltage source, current controlled current source. Okay, here you see this current, this output current is controlled by Is. Is is available in input side. So that's why this circuit, it is nothing but current controlled current source. Okay, here this output current is controlled by input current. So this diagram is a current controlled current source. Then the next question you see, the magnitude of current through resistor R2 in the figure shown as dash. Okay, this is the given diagram. Here the question is to current flowing through this R2 resistance we have to find out. Okay, here you see this is the current source of 10 milliamps parallelly connected with one 2 kilo ohm resistor. Similarly, here you see 2 milliamps current source parallelly connected with 4 kilo ohm resistor. Okay, so our question is to, we have to find current flowing through the center resistance R2. Okay, so that's why, so we can solve this problem in different way. So here I am going to use the method current source to voltage source transformation. Okay, so already that is there is a one transformation is available in circuit analysis. You know, if one current source parallelly connected with one resistor means we can convert the current source parallelly connected with the resistance into voltage source in series with the resistance. Okay, that is a current to voltage transformation. So in that, the voltage source value is nothing but it's a product of the current source and the resistance value. So 10 milliamps multiplied with 2 kilo. Okay, so 10 milli means 10 to the power minus 3. Kilo means 10 to the power plus 3. So if you are multiplying this two, we can get 20 volt. Okay, then seriously connected with 2 kilo ohm, the same resistance. Similarly, you see here also one current source parallelly connected with resistor. So it can be replaced with voltage source in series with the resistor. Okay, what is the value of that voltage source? This current multiplied with 4 kilo ohm. So 2 milli multiplied with the 4 kilo, so 8 volt in seriously connected with 4 kilo ohm resistor, and already 1 kilo ohm available here. Okay, so from that our aim is to find out the current flowing through this 1 kilo ohm resistor. Okay, so you just apply Kirchhoff's voltage law to this circuit. So current flowing through 1 kilo ohm resistor is 20 plus 8 divided by the addition of this 3 resistance. Okay, so the answer is 4 milliamps. Okay, so 4 milliamps is the answer. Then the next question, a network contains linear resistor and ideal voltage source. If the value of all resistors are doubled, then voltage across each is dash. It is halved or doubled, increased by 4 times, not changed. Okay, so in one network, the network consists of some resistors and voltage sources. If all resistor values are doubled, okay, all resistor values are doubled means what is the voltage? There is no change. Okay, since in any closed path, the voltage source value is not changed. Okay, in one circuit, if the resistor values are doubled means what about the value voltage across that resistor? Mean the the voltage across the resistor remains unchanged. Okay, so not changed. This is the correct option. Then the next question, a series RLC circuit has quality factor is 100 and the impedance is 100 ohms and its resonant angular frequency is 10 power 3, that is omega R is given as 10 to the power 7. What about the value of R and L? Okay, R and L value we have to find out. So first you note down the given data, quality factor is given, resonant frequency is given, impedance is given. Okay, so impedance is given. We have to find out the resistance R and L. Okay, R and L. So the impedance is nothing but Z is equal to 100 plus J. So from that, this is the real part. So the real part is nothing but a resistance. Okay, and in order to calculate the inductance value, the quality factor Q equal to omega R L by R. Okay, so here Q omega R given, Q given, R we calculated. You just rearrange. So we can get the inductance value as a 1 millihenry. Okay, so this is the inductor value and the resistor value is calculated. Okay, so thanks for watching my channel and please subscribe my channel for more videos. Okay, so we will solve the remaining problems in the next video. If you want to learn all videos related with the subject already in our channel, in the name of TRB Polytechnic exam, there is a playlist is there. And if you want to learn all topics related with circuit analysis, signals and system, discrete time signal processing, already there is a separate playlist is there in our channel. You just check it. Okay, so thank you. We will meet in the next video.